Hello everybody, hope everything is going all right. I'm going to do 4 quick problems and try and make it a quick one for you, so let's get into it. We're pulling on a rope. We have to lift a 4.25 kilogram bucket from a well, so it has to be able to overcome that mg. And we are lifting it with an acceleration of 1.8 meters per second, so that means that we have a force applied or a force of tension, it depends on what you want to call it, and those would be the sum of all forces. Force of tension is going to win, and it would have to battle gravity, so we do minus mg for our sum of all forces, would equal ma. All right, so then we just solve for force of tension. Force of tension minus 4.25 times 9.81 would equal 4.25 times the acceleration of 1.8. We math, and we would have to take the, here we go. We would have to take the 9.81 times the 4.25, and this would be a minus 41 here, so we'd have force of tension minus 41.69 would equal 4.25 times 1.8 is a 7.65. And then we would add the 41 over. So if we add that 41.69 over, you get a force of tension of roughly 49.34 newtons, which is more than the force of gravity by just a little bit to get it to accelerate. All right? Then we have these equilibrium problems. These equilibrium problems are going to mean that you have to do some fancy geometry, nothing else. This 5 times 9.81 will be right here as well. So 5 times 9.81. That is the only vertical component. Vertical components are the only thing that can hold up the weight of that blob. I don't know what it is. This portion right here and that portion right there, those horizontal portions must also be equal, even if they don't visually look like it. This is a force diagram. It is not a length of the string thing. Okay? So, with that in mind, I'm going to redraw, so I just have a little bit of room. 5 times 9.81 ends up equaling 49.05 for that. And we are provided that this angle right here is 20 degrees. So if that angle right there is 20 degrees, we can use some trig to get this force of tension. So that would be the force of TA. All right, so that is an opposite of the 20 and a hypotenuse. So this would be a sine problem. So sine of 20 would equal 49.05 over the hypotenuse. And if the hypotenuse is on the bottom or the variable is on the bottom, then you have to divide. So 49.05 divided by sine of 20 equals 143.4 newtons. So this part right here is 143.4. From here you have options. You can use the Pythagorean theorem, or you could use sine, cosine, and tangent again. I am going to pretend that I never found that. And if I never found that, I would still have the 49 over here, 0.05, and I would have a 20, and I would just recognize this is the adjacent and that is the opposite, which means I would use tan of the angle would equal 49.05 divided by the adjacent. So again, your variable's on the bottom, which means we divide 49.05, but this time by tan of 20, and you figure out that that adjacent side is 17.85. So if this is 17.85, so must the tension in B, because the horizontal components must always be equal if it is an equilibrium. All right? Just barely off the screen. So those are the easy ones. We're going to do one hard one, and then we're going to maybe start but not finish the last one. So this one isn't that hard, but it is lengthy, A, B, C, and D. So here it asks us to draw the free body diagram. Well, we have this force of tension, but I don't want to think about the force of tension. We have this mg going down. In the first scenario, I think that there is a frictionless table. So in scenario 1, no friction. Let's do the sum of all forces, because in scenario 1, there's only one force, and that would be the mg of this mass going down. okay? And that is a 2.8 kilogram, and this is a... they're both 2.8 kilograms. That's convenient. All right. So in scenario 1, the sum of all forces, you only have mg going down. You do have a force of tension, but we're not going to think of it in terms of force of tension right now. It is going to be mg would equal m1 plus m2a. So this time we're looking at the system, where you look at both blocks as a system, where there is nothing really against it in the system. It's just this system is going down together, all right? And the thing causing it to go down would be the mass of block 2, which is right here. So this would be 2.8 times 9.81 would equal 2.8 plus 2.8 times A. All right, let's do the math for that. That would be 2.8 times 9.81, and then we would divide by the combined 2.8. So divide by 2.8 plus 2.8, or times 2, and we get an acceleration of 4.905, which is conveniently half of gravity. Okay, so 4.905, that's part A, done. Find the acceleration of the masses. They're accelerating together. One's accelerating to the right, one's accelerating down. Find the tension in the string. When you're doing tension, you can only look at the one winner. So now I'm like ignoring everything above it. So for tension problems, you need to look at the winner or the loser, but it's way easier to just do the winner. The winner is going to win. mg minus the force of tension would equal only m2, which was the winner, times A. Okay, so for the force of tension problems, you use the acceleration that we just got. 2.8 times 9.81 minus the force of tension would equal 2.8 times the acceleration we just found. So it's a two-part problem anytime you have force of tension with these moving things. Then you just have to math. 2.8 times 4.905 minus, I'm just subtracting. So I multiplied these, now I'm subtracting that. 2.8 times 9.81, and I get 13.74 negative, but it's a negative force of tension equals negative 13.734, which means the regular force of tension would equal 13.734 newtons. Okay? I think that part 3 does ask you to pull part D. Find the tension in the string if it had a coefficient of friction of 0.3. So if it has a coefficient of 0.3, that means that now this is going to slow this down even more, because we have a force of friction applied in the opposite direction due to the force natural. So in scenario 2, we do have a force of friction. In scenario 2, when we do the sum of all forces to find the acceleration, we would have mg still winning. This is still going to win. Minus the force of friction would equal the combined masses times acceleration, just like before. Okay, so mg is still going to win. That's still going to be 2.8 times 9.81 minus the force of friction. The force of friction is always mu times force natural, which in this case, force natural is also going to be mg. But it's going to be the mass of the guy on the table, not the mass here. They just happen to be the same. So mu is 0.3 times 2.8 times 9.81 would equal 2.8 plus 2.8 times A. All right. Do the math for that. We have to do 2.8 times 9.81 minus 0.3 times 2.8 times 9.81 ends up equaling 19.27227 would equal 5.6 times A, so we divide by 5.6, and we get an acceleration of 3.43 meters per second squared, which is slower than it was before because now there is friction. So now that's the first part. If it asks for the tension in the string, now you do the exact same thing that we did before with this winner only. Winner only meant that we would take the winner minus the force of tension would equal its mass times the acceleration we just found. So the winner is still mg minus the force of tension would equal the winner's mass times that acceleration we just found. So this would be 2.8 times 9.81 minus force of tension would equal 2.8 times 3.43. All right? So if I do the calculations for that, times 3. Minus 2.8 times 9.81, you get a force of tension of 17.86 newtons, which should be more than it was before because now the friction is pulling against that string and it's adding to the force of tension. All right, last one. I'm not doing the whole thing for this. I'm not doing the whole thing. I just want to give you enough to maybe get going because I was worried that maybe you forgot. Here, we have two conflicting forces. We have mg going down here, but we have on an incline mg sine of the angle there. All right, so when we do our sum of all forces, there is no friction, so that's convenient. Now we would have to think winner minus loser would equal ma, but I don't know which one's winning. I don't know which one's losing. All right, so let's just see. M2 has a mass of 3 and M1 has a mass of 1. That would be 1 times 9.81. This would be 3 times 9.81 times the sine of the angle, which is 40. So let's just see which one wins out of those. So if we do 3 times 9.81 times sine of 40, that equals 18.91. So this force going down is 18.91 newtons. Versus 1 times 9.81 is 9.81 down. So which one wins out of these two? Not the 9.81, but the 18.91. So when we do our sum of all forces, we would do winner minus loser would equal the combined mass, which would be 3 plus 1 times A. All right. Almost going to do this whole problem. Divide by 4. Calculating for A, you get a 2.275 meters per second squared. And that would be the acceleration that you would use with the tension in the wire. Now here you have your choice for whenever you do the tension in the wire. I would still do the winner. Just keep it simple. Always do the winner. So the winner was mg sine theta minus the force of tension would equal its mass 3 times 2.27. Okay, so when you do the force of tension, it's the winner minus the force of tension equals the winner's mass times the acceleration we just found. That's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.